Hello, everyone, and welcome. Thank you for joining us for the fifth event in the Meet the Inventor series from IDiyas, the inventor and patent insight platform built by inventors for inventors. If you haven't visited IDiyas.com yet, please do. The site is full of fascinating insights about inventing and innovation from big data. My name is Madeline Key, and I've been interviewing inventors for more than 15 years. First, I'd like to thank our sponsor, Inventor. Inventor is the longtime leader in helping independent inventors and startups license their ideas for new products. Today, our wonderful guest is inventor Mike Sutcliffe, co-founder and CEO of Mobius Technologies. That's just one role among many that we're going to discuss today. Mike is joining us from his home in Inlet Beach, Florida, I believe.
That's it.
Mike, we're thrilled to have you here with us.
Thanks.
Bear in mind with me as I read your bio, which is exceptional. Mike Sutcliffe is a distinguished business leader recognized for his exceptional contributions to the digital landscape. With a career spanning over 30 years at Accenture, the IT company that services over 9,000 clients across 120 countries, he left an unmistakable mark on the technology and business sectors, notably as the visionary behind the creation of Accenture Digital. Upon retiring as CEO of Accenture Digital several years ago, he embarked upon a new entrepreneurial chapter. He's now co-founded 3 groundbreaking startups. The first is Cherish Health, which is dedicated to revolutionizing the healthcare solutions industry. Headvantage Fan Experience, which is focused on enhancing fan engagement in sports. And Mobius Technologies, which is driving the development of immersive AI as a revolutionary new class of computing, of creating entirely new digital experiences. He holds a bachelor's degree in electrical and computer engineering and a master's of science degree in business from the Georgia Institute of Technology. Okay, everyone, just a little bit of housekeeping before we move on to asking Mike some amazing questions. I know many of you prefer to leave the IDiyas screensaver on with your cameras off, but part of the fun and engagement of this awesome platform is seeing your faces. So please do feel free to turn your camera on. We would love to know where you're attending from. Please write into the chat box, which you have to click to open at the top of the screen, and let us know where you're tuning in from. I've prepared questions for Mike, but we'd really love to hear your questions. So please share them in the chat box. We might not be able to get to every question, but we're going to do our best. Okay, Mike, let's leap right in. We've got a lot to talk about today. This month, you've debuted new products, or are about to, for your 3 different startups. So first, this is a question I like to ask of everyone I interview in the inventing space. Do you think of yourself as an inventor, and why or why not?
Yeah, I guess so. I mean, I've always enjoyed trying to solve problems that hadn't been solved before. And so, one of the reasons I like to cross between engineering and business was to be able to see the business problems and think about how to apply engineering, and vice versa, how to get engineering expertise into markets that make sense. So I've always thought of myself as someone who likes to solve problems. I guess that's probably why I picked a career in consulting. So I like to get new problems every week, right? Something new to work on.
That's a great point. When and how did you begin learning about intellectual property, like patents?
Wow, gosh, I guess the very first year I joined Accenture, I'd just come out of graduate school. I just passed the CPA exam, and I was writing some financial software for a brand new product that we were going to bring to market. And so I had to work with the attorneys to learn about, how to understand the current market, what was out there, what patents I might be stepping on inadvertently, and then what patents we might want to file based on the work that we were doing. And so I was very young. I was just right out of school, 27 years old, I think, when I was filing my first patents. So it happened early in my career. And, I created some patents just a year later in a completely new area. And then Accenture has Accenture Labs, which had, 300 PhDs that were doing different types of research. And I spent a little bit of time getting to know the labs and how they operated. And they taught me a lot about collaborating with others and understanding and respecting other people's intellectual property, as well as thinking about your own.
That leads me to a different question. When you talk about respecting other people's intellectual property, do you mean getting really good at maybe searching for prior art? So discerning, what has already been invented in the field, or what do you mean by that?
Yeah, I mean, being thoughtful about understanding what exists, why it exists, how it's currently been used, and sometimes it's just taking other people's existing capability and applying it in a new situation. And so, you don't want to mistakenly claim that you've invented something you didn't, right? So you want to understand not just what the obvious applications of existing technology are, but how else that existing technology might be used. And sometimes combinations of a couple simple things can look very, very interesting, but in fact are not actually very novel.
Okay, that's fascinating. So you're learning not only about the history of innovation, but how to take it forward by looking into other patents, other spheres.
Yeah.
Do you have an invention that you're most proud of, or that you would want to speak to at Accenture particularly?
Well, my first one was really very early in the days of artificial intelligence. We did something that most people thought would be the most boring thing that you could work on, which was corporate taxation. And we had a client that had 121 different general ledgers, so 121 different sets of financial books. Each of those financial books had to be converted to tax books, and then each of those had a tax return. Those tax returns all had to get compiled into a corporate tax return. And that took on average about 2 years for the client to go through. And because they weren't able to do it in a timely manner, they had to file extensions to their tax returns, which meant they had to estimate their tax liabilities. And for them, that they could be off by $50 or $100 million on the estimate, which either meant they consumed extra capital or they paid a lot of penalties, right? Depending on which way they missed. And so our very first system was kind of pressing the edge of what the hardware could do at the time. We used the first Pentium chips and wrote the first AI systems, and we installed that software in all 50 of the top 50 companies in the United States. And we took their average time from filing from a couple of years to a couple of months. And so that eliminated a lot of the guesswork that was going on, and it eliminated a ton of the actual work that was going on to do the thing. So for me, that was interesting because it was a really early application that wouldn't have been possible even a year earlier, because we just didn't have the compute power to do it at the scale that we were trying to do it. So that was a long, long time ago.
Feels like you were in the right place at the right time, like the sensitivity of that. When you were talking about all of the paper that was created, I was just thinking, what a headache. You must have vastly improved the quality of a lot of people's jobs, let alone saving those companies a lot of money. The scale of that impact is really dramatic. Did that get you excited for your next invention, or get you thinking differently about the nature of your work? Or was this, solving a problem for clients that resulted in a patent?
Yeah, I enjoyed the challenge. Oh, sorry about this. Alexa, stop. Sorry about that. So I just enjoyed the challenge of learning and thinking about how to solve the client's problems. And typically I got called in for clients that had already tried to solve the problem 4 or 5 times and had failed. And so the question was, is it solvable? And if so, what would be the combination of changes in the process, the technology, the strategy that they were employing to try and create a different problem outcome? And so to me, that was the interesting part of the work, right? Is trying to solve something that others had seen and not been able to solve yet.
No kidding. How many people did you work on that together?
On that particular project, it was very small. I think the team was 9 people. But a true story is that it was the night before Christmas. We had to get this project done by December 31st, and I remember it was the night before Christmas. I was right out of grad school. I was working. We were just up against the clock, and I was on the phone with Microsoft, and we were debugging a part of the system that wasn't working, and I was convinced that the answer they were giving me was just incorrect. And so I was running some electrical and computer engineering tests on the IO subsystems, and I just said, your code's wrong. It was the Windows code at the time. I said, it's not processing on the Pentium chip the way you think it is. And I remember a guy came on the phone and he said, well, what do you think is wrong? And I said, this is my guess, but I can't see your code, so I'm just guessing. And he said, well, let me go look. And he came back a minute later and he goes, okay, I've rewritten it. And he patched it over to us. He said, run it again. So I ran it again and it worked. And I said, oh, thanks. I said, who was that? He goes, oh, it's Bill. It was actually Bill Gates. He actually rewrote the code on the spot on Christmas Eve. So
Wow.
yeah, so like, you know, he was working hard at the time. And we did get the project done literally on December 31st, right in time. And so, you know, sometimes you kind of get to see the real leading edge of the industry and appreciate how, you know, how hard people are working to make that last mile work.
No kidding. That gave me chills a little bit. Yeah, entrepreneurs are in my experience, exactly the type of people you would imagine to be up on the 31st, working late into the night. Okay, well, this brings me into a good follow-up. Where, when you're trying to solve a problem like some of the ones you've described, where does an idea for a solution come from? What inspires you?
You know, the first thing is I don't remember where or who the quote is from, but I remember a quote that said, the more dots that you see in life, the better your chances of connecting them. And so I had a habit very early in my career of one of my mentors said, you should read as many magazines as you can, but the discipline is you have to read every page every time, no matter what, even if you don't care. And I was like, oh, that's tough. But I read a lot. So I read science magazines and business magazines and sports magazines and, you know, political magazines, et cetera. And I tended to try and just absorb knowledge, right? And then you start to see the patterns in the articles. Okay, here are the patterns in the articles on this topic. Here are the patterns of the articles from this writer. Here are the patterns of the articles from these magazines, et cetera. And you start seeing patterns of dots, right? And then you start seeing that there are some connections that you didn't know when you just read one article. When you'd read the 10th article or the 100th article, you started to say, okay, I can see these patterns. And that kind of created a game that I used to play with myself, which is just like, can I connect dots I haven't seen before? And to me, that's where I usually found the invention, right? Was nothing that I was doing was incredibly original. It was just connecting things other people were doing in ways nobody had connected before. And that's probably true with everything I've done in the past 3 years with all of these startups. There's no individual piece of the technology is brand new, but some of the concepts and the connections are what's new.
That's fascinating and really great advice. I sometimes get this sense that people think they need to learn more about one thing before they're qualified to be an inventor, that they're not enough of a subject matter expert. They want to compare themselves to someone like Thomas Edison or Nikola Tesla, and they find that they fall short. And what you just did with that advice was make invention accessible to all of us, because it's saying, no, it's about creating these patterns and it's about linking them. You know, but it's not only just a matter of seeing those patterns, it's being courageous enough to be the one to realize, like one of our first guests mentioned, no one else maybe is seeing that pattern. No one else realizes that they should be the one to solve that problem. I'd love to fast forward a little bit into your mindset in leaving Accenture and stepping into that role of entrepreneur and taking on so much responsibility to not only connect the dots, but then bring them to the masses.
Well, you know, the decision to leave Accenture was, you know, pretty simple. The board told me they picked someone else to be the final CEO candidate. And I thought it wouldn't be fair for me to stay if I wasn't going to be the final candidate. So I thought, well, you know, I've had a great career. I've enjoyed it. I could obviously just go be a CEO somewhere else. But really what I wanted to do was keep solving problems and doing things I cared about. And so I have some aging parents, they're in their 80s, and I started looking at the state of elderly care. And I took a couple months to really dive into all the existing hardware and software and other products that were out there. I went and I'd spent some time in healthcare in my career, so I went and talked to some of the experts in the field. And so Cherish was about cherishing our elders and trying to create elderly care solutions that just didn't exist. And when we looked at the question about why technology wasn't being very useful to elders, you know, you start with the obvious, like they can't see the user interface on a watch because their eyes aren't that great, right? So if you're expecting them to do what I do on my little Apple Watch and, you know, twist the dial and pick the third thing in, you know, not going to happen. But even more basic, they're going to forget to charge it, or they're going to lose it for a few days, right? And so you start to look and say, well, you know, what are the challenges with all of the devices that we've offered? And can we create something that's so simple, so intuitive, so easy to use that it's always working 100% of the time? Because if you're trying to provide care, you don't want it working 80% of the time or 50% of the time. And I looked in the personal emergency response, the PERS market, where people wear the little monitors to tell us, did they fall down? Are they okay? And that they had a false positive rate in that particular device market of more than 50%. More than 50% of the time that somebody was getting a call saying your mom or dad fell down, they didn't fall down, right? And so what happens is people just stop wearing them because they're like, I don't want my son getting a call saying I fell when I didn't. That causes a whole other conversation I don't want to have. So we thought, well, okay, can we do something where we could be 99.9% accurate as opposed to wrong half the time? And then we said, well, could we do things where we don't have to like go find the device and touch it, but can the device just be in the environment? And for example, would it be possible for the device to know my heart rate and my breath rate without me touching the device? And at the time, the answer was no. So then the question is, well, why not? Like there is technology that could do that. Nobody had put it together in a device in the home. So we started looking at, what could we do to create a device that would have a really easy user interface. So no keyboard, you just talk to it. It would be completely edge-based, so it's not sending private data to the cloud, but it has the ability to send signals that can coordinate care. And so we just started working. We founded that business on campus at MIT. We got a bunch of PhDs from different areas at MIT. I think we had about 14 of them from different parts of the community coming together and just having brainstorming sessions. So how do we solve this problem? How do we solve that problem? How do we solve that problem? And after about 9 months of doing that, we were like, it's actually possible to engineer a device that does this. Now we have to actually write all the AI routines and, make it actually work. But we did that. And then we tested it with patient trials in 5 different countries. And now we're just about to introduce it into the market. What was interesting is we started with elderly care and we still are providing a whole bunch of new capability for elderly care. But it turns out it's fantastic for SIDS monitoring for babies. It's fantastic for kids with childhood asthma. It's fantastic for heart patients. And so we didn't intend to solve those problems, but because the device we created for the elderly care market has these new capabilities, the healthcare industry just responded and said, well, here's a bunch of other problems that also solves that you weren't even thinking about, right? And that's why it's fun to kind of watch these things come to life. And so during COVID, I remember so my co-founder and the CEO of that company is a guy named Sumit Nagpal, who's up in Boston. And there was a center there for military veterans. And they were struggling with, what do you do? We don't want to keep them in the center because COVID can run rampant in this elderly population. But we also don't want to put them in hospitals because that takes up all the beds. And where do we put them? So we just created a little wearable device that you can stick on your skin. And for 2 weeks, it would just give you all the same readings that you would have if you were in a hospital. And then we could just easily connected it to the Bluetooth that was already on their phones. And then we put it in a 24/7 monitoring system. And we just had physicians monitoring that particular population just to know, out of all of those veterans, who were the ones that needed the urgent care and needed to be brought in for treatment versus those that could stay distributed and away from others so that they stayed healthy. That wasn't a problem we set out to solve when we created the company, but because of what we had already done at MIT, it was super easy to just miniaturize it, put it into a bandage that could stick on you with microneedles, and then we could get all those readings. So that was something we did just to help with COVID. But the broader question of how we actually solve the longer term problems is what we're really focused on.
Wow, how fascinating. So it sounds like to me you're moving out of maybe knowing how to solve a problem yourself, but more saying, hey, this is a bigger problem that I know how to marshal the resources, how to build out a team, how to raise money, because in just a few years, you've already been touched by so many different organizations. You're working in health, you're working with the university. That's remarkable. Did you mention that Cherish, that product will actually be available to purchase for consumers this month? Did I understand you correctly?
Yeah, so they've just signed, Cherish has signed national distribution agreements with both AT&T and Alarm.com. So we're just literally receiving the first boxes, I think last week, and we're getting them out to the distribution centers. And then those sales teams will start taking them out into the market. So I'm guessing in Cherish.com's health their website will also sell them to you directly, but you'll probably be getting them in the market through AT&T and alarm.com. And then we're also working with the healthcare providers, the Aetna, Cigna, companies like that, that'll be introducing them into very specific patient populations that have a need for that device on an urgent basis. So hopefully by the end of this month, we'll actually see them, in customers' hands. I actually have one on order. I'm waiting for mine to give it to my parents. So
right.
yeah.
Well, congratulations. It's super exciting to be here with you on the cusp of this moment. And thank you for working hard to solve that problem, because to be honest, the help I've fallen and I can't get up is almost such a comical product that it spun its own kind of memes and jokes. I think a lot of people are aware that that's not that great of a solution to what's a really serious problem. So it's exciting that you've been working on that.
Appreciate it. I see we have a couple comments on the side. Edgar, thanks for the Steve Jobs quote reference. I know Steve also said you can only connect dots looking backwards. You can't connect them looking forward, which I thought was an interesting observation from Steve. And then I think Josh noted that Bill's a fellow inventor here at IDiyas, so that's interesting. And then Melanie talks about the pattern recognition games with kids. I actually did that with my kids the whole time they were growing up. And what we used to do around the dinner table was we would pick the topic of the day, and we would pick 3 or 4 different sources of news. And we would compare the articles, and we would ask the questions like, who wrote the article? What was their objective in writing it? Who was their intended audience? What were they trying to convey? What evidence did they provide for the article? What arguments did they provide against the article? And at the end of it, it's a balanced article, and do you believe it? And what's interesting is both of my kids tell me that they still use all of those questions every day in what they do in their day jobs. Just do I understand the information that I'm receiving and why it was produced and who produced it, and
yes.
And so that was one of the games we used to play a lot. So we did that. And then I see Edgar's also got a question. What do you do with this once you retire? My daughters both tell me I've failed at retirement. So I don't think I know the answer to that one.
Yes, I would say you have totally failed at retirement. Please share a little bit more of the technology that you're working on at the other 2 companies you've co-founded with us.
So I have another co-founder named Jay Headley. Jay and I actually invented, when we were at Accenture, we invented the concept of you going through a toll by just reading your license plate. No device on your car, nothing in your window, no stickers, no magnetic devices. So we called it, touchless electronic tolling, just using cameras that were looking at your car. We started it in Washington, D.C. on the Dulles Expressway, mainly because Jay got stuck in traffic all the time, and he wanted to know, why isn't there an easier way to get through the toll booths? And so we actually own the patent on tolling that way. But Jay and I, when we left Accenture, he wanted to know, why can't I see what Tom Brady is looking at 1 second before he snaps the ball and 1 second after he snaps the ball? I want to see it in real time. And the problem is, I could put a camera on his head and show you the field of view. That doesn't tell you what he's looking at. Now, Jay was a fighter pilot. And when the fighter pilots were training, there was a camera looking at their eyes as well, trying to understand what were they looking at while they were actually firing the weapons, right? And we said, well, why don't we take that idea of one set of cameras looking at you? So we had infrared actuators, 2 actuators looking at each eye. And then we have a camera pointed at the field of view. And then we just mixed into that, a battery, a CPU, a communication capability, and then a package of sensors that include shock, GPS, rotation, speed, et cetera. And then we said, okay, what we want to be able to do is we want to be able to combine all that information, send it out over whatever communication protocols in the local environment, and then get a high definition video composite with all that data with less than a half-second response time. But then you have to engineer it into a package that you could put inside of a helmet. And if you've ever seen the face mask on those NFL helmets, right? They're made out of very, very good material, and they're designed not to break. And I think the statistic in the NFL, I have a nephew who plays in the NFL. He said the statistic was that they 30% of those face masks are broken in a game. But that's how hard they're hitting each other, right? So the G forces in two football players hitting each other are astounding. And so we had to make the device 4 ounces, so it fits inside the shell of the helmet. And it can't be any pieces that break off and land on the field and that kind of stuff. So basically, we've created the capability for either a hat or a helmet to put the field of view camera with the infrared actuators looking at your eyes. And what we do is we take the little circles and we show the reticles, like where are your eyes looking inside the field of view in real time. So you can literally see the eyes of the quarterback and know he's looking right there at that player right now, 1 second after the snap. And here's what he saw. Here's why he missed that the receiver was open. Here's exactly what he could see from where he was. Because if he's 6'3", it's a different thing than if he's 6'1" and he's got a person coming at him. So that's the experience we were trying to give the fan. And we've developed that. We've got some more work to finish on rewriting the routines for tracking the eyes at that distance. Mm-hmm. So we've all the geometry changes from the eye tracking that's been done before. But we've got proof of concepts that work well enough. And then the question is, what else can I do with it? And so we're working with the NFL on real-time concussion protocol. Because we're looking at the eyes 120 times a second, we can see the divergence, we can see the pupil changes, et cetera. And we can correlate that with the rotation, shock, GPS, and other data. And then we can start to look at who was hit, how hard were they hit, at what angle, at what part of their head, and then correlate that to what's happening in their eyes. And so one of my daughters happens to be a neuroscientist and a clinical psychologist, and her teams work a lot with the NFL on concussion protocol. So we're now writing a grant to do the real-time concussion protocol for the NFL. So now it turns out that that's useful for other things in the NFL, right? So we're starting to test where else we could use that particular technology. So that just got used in kind of live use last month with the Golf Channel and with the Caribbean Cricket League, the Premier League. And so we had about 20 million people that saw cricket from a different advantage or a different vantage point than they've ever seen it before. They actually saw it from the eyes of the umpire. So you literally see the bowler coming right over the umpire and throwing, from that angle, which you've never seen before because no one could get a camera there. And now we're starting to explore it with all sorts of different sports and non-sports applications. The next thing we're doing is with the U.S. ski team. And what the ski teams, the coaches have said is we've never been able, like we know we coach people where to look for the gates, but we've never known for the best skiers when and where are they changing their vision and what are they looking at? How far ahead are they looking and when and how quickly do their eyes move? When we tested this with the Formula One drivers, we found out that the response time of the eyes for the Formula One drivers was about 10 times faster than normal humans. I don't know why, just it is based on what we've observed so far. So you can start to see the differences in ability of people to absorb and process information by tracking what they're doing and how quickly they're doing it.
That is so fascinating. Wow. How long have you been working on that? How quickly did it come together?
So we started all of these in March of 2020 when I retired from Accenture. So we started both of those businesses right after that. And then I started Mobius, which is the third company, in November of that year. So we've been doing that for almost 3 years now.
Speedy to be talking to such large groups. I mean, where my mind starts going is like, yes, for the fan experience watching, but then also, like you mentioned, if you're learning the sport, if you're trying to get better or improve, where your eyesight is directs kind of your entire focus, your balance. I've been trying to learn to surf. If we can figure out how to get it in the water, I would love to see where my favorite surfers are looking exactly. Congratulations. I think that's something people really want. I can imagine it almost in video games of people getting a more precise understanding when they themselves are performing like their favorite athletes. And now this technology, I had the pleasure of getting a demo and it totally blew me away. Would you share a little bit what you're working on with us at Mobius?
I would be happy to. So at Mobius, we started with a really simple question. So I traveled all over the world and was frequently asked if I could present to multiple audiences at the same time, and I just couldn't. Can't be everywhere at the same time. And so I thought, gosh, would it be really interesting if you could put yourself in a PowerPoint presentation, and when the person opens it, you're actually there. Now, you could always just put a video of yourself in there. The problem is if you video more than about 30 seconds, the file becomes so big, it's not easy to send it to them on email. Then they have to trust you and go to a file sharing site. Mm-hmm. Corporations don't like doing that. So, so nobody puts long videos inside of a PowerPoint. So you don't really explain things. And so you kind of need to be there live to get the effect, especially if there's a real depth of expertise to get across with the content. And so then we said, well, I actually don't want to be there recorded. Sometimes I actually want to be live in the content, but it's not a video call. It's just somebody is opening a document I've sent them, and I want to be live inside that document. So we started with the question on PowerPoint, but then the question was, if I could do it in PowerPoint, can I do it in an Excel spreadsheet or a PDF or Word or any other Slack message, whatever? Can I put that human presence live in all those places? So we figured that out with a brand new approach, a technology we call AirPin. Mm-hmm. And when we figured that out, that if you can move live video into any kind of a document, you could pretty much move anything you want to in there. You could make the whole document have layers of content that are live. So for example, if I'm a drug company and I'm sending out a new product introduction to the industry, the regulators say the drug monitoring, the pharmacovigilance data has to be updated on a regular cycle, like every 30 days. So that industry is constantly producing documents, sending them out, then destroying the documents, producing new documents that say exactly the same thing. They just have updated data, right? And they're sending those documents out. And those documents sometimes circulate for months on time before somebody opens it and says, okay, now I want to look. And by the time they open it, the document's not good. So, so what we asked is, could we just make all of the contents of the document live? That was pretty easy. Then the question is, can we make them interactive? Can we make it a two-way communication inside of a document? And so I'm going to show you a PDF file now, and you'll see a new account opening experience that happens inside of a PDF file. And so here we'll try and play that if I can pick the right window. And let's see if I've got it. Okay, here we go. And hit share there. Oops. There we go. Okay. So you should be seeing a document that's here, this little Chase document. And I'm just going to narrate over this as it goes. So what you're going to see is that there's a document that's being opened. And when we open it, you'll see that there's a person floating above the document. She's not in the document. It's a layer of content on the document that's there because that little thing that looks like a computer is up there in the corner. We call that an AirPin. And the AirPin can be visible or invisible to the human eye, so we can make it so that you don't see it. But it could also have been the Chase logo or any other design that we want it to be. And you'll see that someone clicked on that little thing and said, I need some customer support. And somebody jumped into the document. This customer support person can see the document that they were called into. And they can start to answer questions. There's an ink system in there that they can write on the document, and they can help you with basic customer service. In this particular case, he asked, hey, I want to open a new account. So now that I've seen this, I realize I've been mixing some transactions. I need to open a second account to keep those transactions for my new business separate. And so he asked him, can you take me to the lobby and let's go open an account? So we just took you to a lobby. This one happens to be a 2D lobby. In a minute, I'm going to show you it could easily be 3D. And what it's doing is it's using the camera, it's scanning the driver's license, running a credit check, pre-populating a form, having that form come up, allowing you to edit it, co-edit it. So both sides can edit it. You can sign the form. And then once this form's signed, we're doing a video attestation, because sometimes the regulators need to know that you were given the right product information and that you've successfully, agreed to open that particular kind of a transaction. And so this is all happened right inside of a PDF file. And the reason that's important is because it happened where we got your attention. In this case, it was, you got an email, the email had your account statement, you opened your account statement. when you were in your account statement, you realized you needed some support and you just called someone into the document you had a question about. And it eliminates all that time in customer support saying, who are you? Why are you calling me? You know, what's this about? Oh, let me get your data and bring it up. Like we just took 40 seconds out of that whole conversation because now I know who you are. I know what document you called me from, and I am immediately connected to my customer service support. And now I've got a set of tools that can give you other experiences. So that same thing is, it works just fine inside of a recorded video. It works inside a broadcast video. It works inside of a screen share. You can do it anywhere. Okay. So this is what we call AirPin. Now, AirPin can do some interesting things when you put it in a video. So for example, as the video is playing, I can activate different layers. Like if I'm watching a music video and I'm trying to learn the tune, I might say, I want to see a layer that has the score sheet, right? And I want a transparent layer over the video. Or maybe I want to learn the lyrics and I want both the lyrics and the score sheet. Or I want it in a different language. So I want the score sheet, but I like it in German. Or actually, I just like the guitar and I want to be able to click on the guitar and buy it right now while I'm watching the video. Well, that technology doesn't exist in video, right? What we have today in video is jump skip technology around the video. Or if I'm the content creator, I can say, hey, in my link, I put a connection. If you like my guitar, click on the link and then I take you somewhere else to buy the guitar, right? But for us, it all happens inside the content that we started with, right? So that's what that one was about. Now, what we've done is we've taken that and we've said, well, we can go from, from that to doing something a lot more interesting and useful for people. So we have another product that we're just about to introduce. And in fact, it's out there now in beta and you guys can all try it after you see this video. And this one is what we call Air Screen. And this one is going to show you cricket because this is the month of the international cricket matches. And so the World Cup is being played right now. And this is a thing where what I said is, hey, we've got a lot of people who are sitting in, coffee shops, planes, trains, automobiles, places where they are not sitting in front of a TV and they're trying to be productive on their laptop, desktop, etc. So could we just create a layer inside the computer where they can watch what they want to watch, but still be productive? And that's what this one does. So here you can see that we just have a standard computer. You have all of the functionality of the computer available to you. And what's happening in the background is you're able to watch any streaming video source that you want to, that you have access to. And you can dynamically choose how to change the transparency layers between the foreground and the background. And, this is useful for everything from sports to putting a Zoom call in the background. So if you want to take notes and do other things while you're on a Zoom call, you can do that. Yeah, exactly. Yes, I want to do that. Some people come back like, I've got friends who just had children and they like to watch the webcams for their childcare center while they're at work. My daughter likes to watch her dog, who she's got on a webcam. And so you can see this product is, it's available. It's in beta right now. This is something we're going to offer for 99 cents a month or $9.99 for the year. It's a toy, but it's a useful toy, right? It's something that we thought people would find useful. So from there, I think we go into a more interesting space. And the interesting space is when we go from 2D to 3D.
Right.
Now, when we go from 2D to 3D, what we find is the big challenge is that we need goggles or glasses to see into 3D. And we need a wearable, a gaming controller, or something to interact with the content in 3D. So what we did is we developed a technology that just uses your existing hardware on your laptop or desktop, the same thing you're using for this call, whatever it is, you can now see into 3D and you can touch it and interface with it, and you don't need any hardware, okay? So I'm going to show you a simple version, and then I'll show you a little bit more complex application of the technology. And where we are today is we can take any combination of 2D spaces or 3D spaces, 2D content or 3D content, and either recorded or live human presence and mix it and match it at will. And that's really what this technology is about. So I'll play this one.
Okay.
And one of the co-founders.
So you'll see Richie's just using his hands to make things. He's just holding a hand up and he's connecting to content. And he's just grabbing those slides and he's presenting to you. And you can see that that he can actually interact with that content just using gestures. And
He's using his own hands, just putting them in front of him, and it's engaging with the screen as if we've merged, and he can pull out something that he wants to see or highlight.
yeah, and you can see he's just grabbing the next slide. In a minute, he'll just do this to move between slides.
Wow.
He can draw on these things. He can just grab a pen out of the air if he wants to. So
Really?
you can see what he's doing over here on the left side now, right? This is
as well as my face.
so he's got both an interactive attention and a viewing intention. And you can see that he's just moving, like zooming in, zooming out like this, right?
Okay.
Sky and blue ocean. It's a
Wow.
virtual smart class.
So that's just a new set of technology that we've invented. We call Air Vision. And Air Vision allows us to look. Now, it's not immersive 360 degree. We're not confused, right? If we look at where the technology that we have today is, we would say, well, the technology we have today is, let's just call it Internet 2.0. And maybe the where we want to go is Internet 3.0. And what we want to do is, how do we get from one to the other? How do we get from 2.0 to 3.0? And so what we're doing is we're giving you 2.5, right? What I just showed you was it's not 3.0, but it's not 2.0. There's somewhere in between. So where I don't need it to be 360 degree immersive, it's not, but it's more immersive than just looking at 2D content, right? And what we can do now is we can play with depth. So I'll show you one final one here where what we've done is we've created a virtual tour. This one is for Disney. And what Disney wanted to know was, can we take human presence and make it part of a digital twin tour? So this is just a digital twin that they had. And so what's happening here is you can see that Matt on the right side is just moving his head left and right. And that's what's changing the viewing angle here. And he and Alan are talking. They brought up a little wayfinder to show them what's going on. Alan's pointing that they should go out and look at the ocean. And as they go out here, you'll see that there's a little circle in the ocean. And that's a local tour option that you could go on a little snorkeling experience, right? And so you'll see Matt goes, hey, I think I want to try that. So he just puts his hand up and touches enter. And now they're snorkeling, right? And they're going through and they're taking a look, and they've got some simple controls where they can move around and kind of see what's going on. And then they'll go back and resume the rest of the tour. In this case, Disney wanted to be able to transact. So they wanted to pull a website and they wanted to bring other details in. And so we just, pull in 2D content into this 3D digital twin. I would prefer it if it was a 3D website. It would look cooler. And then some additional information. So this is just an example of taking 2D and 3D and kind of mixing it together and saying,
Sure.
It's a different experience than what we've been doing in the past.
Certainly. I mean, the question on the tip of my tongue is, this is, to me, it feels so very new. I'm so curious how you pitch this to investors. What was attractive to them? Was it a demo of the technology like that? Was it spinning them a story about what this is going to do and how it's going to change? I'd love to know how you were able to raise, I believe, $24 million last fall, because the mind just kind of explodes in seeing that. Or how much did you even share? I'm curious too.
Well, so, I've only shown you about 10% of the different things we do with the technology.
Okay.
So we've got literally, so many horizontal plays with the same underlying capability.
Yeah.
So when you start saying I can mix any combination of 2D and 3D spaces, content, and people, and I can do it with no headset and no wearables, then all of a sudden I can make every website 3D. So for example, everyone on this call will know that if I wanted to build a website, the style sheets that we use, the technology that's out there, include the X, Y, and Z axis. No one's ever activated the Z axis because you would have to assume your audience watching the website's got goggles on, right, in order to see it.
Right.
They can't get depth perception without the goggles. And so since I don't have depth perception without the goggles, I can't float a button off the website and make it look like it's closer to you. But with our technology, you can. So you would now start to rethink websites. And so what I just showed you, that Disney experience, that happens inside of a browser, right? So now we can start to say, well, what does that mean for website design? What kind of services can I bring into a web browser now that I couldn't have done last year? And now there are libraries of 3D digital twins being put together that people have not really been able to interact with easily, and now they can, right? So those are some of the questions that we're asking. But what we've done is we've said, look, we're going to work with my old firm, Accenture, as well as many others, and we're going to ask their industry experts to tell us, what would you do with the technology?
Right.
And so, you know, the Disney idea came from one. We have another one with UPS. We just sold something to Saudi Aramco. We're doing another thing with Neom. We've got another one going on with a large insurance company and obviously a large bank. And they're all different, right? What they want to do with the technology is very, very different than what I would do with the technology. So we're just trying to let them tell us what would be interesting. And so we don't think of ourselves as a product company as much as we do a technology company that's going to license the technology components out. And it doesn't matter to me if you put them inside Salesforce or SAP or inside of a marketing engine or a standalone product. You know, it doesn't matter. It works everywhere.
I mean, I don't think I'm exaggerating when I say this is a total game changer. When are we going to start feeling the impact of this on the websites that we visit? Can we already? It seems so new.
Yeah, it is new. So first of all, the question here was, which was the 24 million in funding? That was the company I'm the CEO of, called Mobius. And the obvious question everyone asks is, who gave you all the money? And the answer is just high net worth individuals that enjoy technology investing. So you might call them angels, but bigger than normal angels. And we only have one institutional investor, which was $500,000 out of the 24. And that was Accenture Ventures. And I just let them in because they were my friends. You know, my whole life I spent at Accenture. And so, you know, what we're trying to do is now get from the 30 patents and all the work we had to do to engineer the technology so that it works on any kind of a device. That's done now. So what we're doing is commercializing it and starting to put it in the market. And so AirScreen, which you can just go to get-airscreen.com and you can download it and use it right now. Or AirGlass, you can just go to airglass.com and download it and use it. They're both in beta testing right now. AirGlass is what you saw Richie doing, where he was in the slides, and we've got a 2D version of that we call AirGlass that allows you to present into Zoom, Teams, whatever you're presenting into in video. But it includes what we call hotspotting, which we use AI to look at your slides and automatically hotspot what's in your slides. We have an entire electronic light board, you know, so that you can, anybody in the call can collaborate in different color ink and all that kind of stuff. So AirGlass is in beta test right now. We're doing beta testing with about 20 clients to get their feedback on how they would make it better. And then from there, we're going to start working on AirPin, which is, I think, the most powerful technology. And we're doing AirTour, starting with Disney, but then we're bringing that into the residential real estate market and the commercial real estate market as well. So, you know, we're trying to get the technology out there, but we're a small team. And we're scrambling to kind of keep up with the market right now.
Certainly. I mean, if you're going to be licensing this technology, then really your intellectual property is extremely important, because that's, you know, will be part of what you're licensing. I'm curious to hear how you decided which patent attorneys or which patent law firms to work with as you built out that portfolio.
Well, that's a great question, because it's, you know, it's a little bit like finding, you know, a partner in business. You know, there's a certain amount of luck of getting the right team, but you can change your luck by doing your research and understanding how these different groups work. So the first thing that we realized is that what we were building did not have prior art. Remember, I talked about respecting other people's intellectual property. So everyone tells you not to do patent searches. We did a ton of patent searches. We tried to understand, what are people?
You got a patent search.
Yeah. So
bizarre advice. Whenever I hear it, I'm like, no, you need to know.
You need to know. So we did all the patent searches. We looked at what was possible, and we said, okay, we think what we have is a new class of computing that we call immersive AI. That was our assumption. And so we said, okay, well, what I'm going to do, I'm going to go ask who in the industry did the best work in related areas. And those are usually small boutique firms that are specialists around different technologies. So we went and hired 2 or 3 of those specialists, and we just asked them to confirm our prior art searches and tell us if we were missing anything. Like we thought we understood, but they had way more expertise than we did in those specific areas. At the same time, I knew that we were going to be processing a lot of patents. It wasn't 1 or 2. We knew it was going to be 20 or 30.
Right.
And so we laid out a patent strategy, almost like a chess game, right? So what are the foundational patents? What are the design patents? What are the utility patents? What are the schools of patents that we're going to try and file? And then where do we want them to land in the patent office? Who do we want our examiner to be? And so we chose Oblong, which happens to be the firm that has the most number of accepted patents every year in the United States. And we interviewed Oblong and several others, and we said, how do you work? Why do you work that way? If we work with you, who would be on our team? How devoted would they be? If we're going to go through 20 or 30 patents, how would we manage that over the next couple of years? Because it's not a fast process to do that many patents. And then we said, and are you open to working with the specialists that we are already working with? Because as we do this, we want the best of the small boutique world with the large industrial strength. And then we interviewed all of the people that they wanted to put on the team. And we said, we had about a 50% hit rate between the lawyers they were going to assign and the people that we thought we wanted on the team. And then we sat down and we walked through the patent strategy with them. We said, before we try and write a single patent, here are the families, here are the groupings, here are the areas in the patent office that we want to target. And here's how we're going to write the common language across all the patents that will allow us to support the patents over time as we file them, so that we get logical extensions and continuances and things like that. So we kind of had the big picture. We estimated the time, the effort, and then we said, okay, what are the blockers that we have to think through? Like if once we start filing, and you can either make them public or not, depending on how you file, right? So provisional versus non-provisional and all those things.
Right.
When do we want to alert the industry that these inventions are there? And in what sequence do we want to alert the industry that they're there? And so we filed, and we thought that the first patents would take 2 years, and 4 months later they got granted. And so we called the patent office and we said, we weren't expecting this. What happened?
Yeah.
Yeah, and we ended up with the most senior examiner in the patent office, and he explained to us that it doesn't happen very often that nobody can find prior art.
Right.
So when that
I've
happens,
actually never heard of that happening.
yeah, it just gets escalated, right? So it got escalated to this guy who was the most senior examiner. And he said, my job was to go find the prior art because nobody else could find it. And he said, when I couldn't find it, it intrigued me. So I kept the case. I decided to keep it. And then he said, and I don't think you guys have hit the boundary of what I would approve. So he said, tell me, what your continuances are. We already had them all written. We were just waiting to submit them. And so the way that we thought about it is the very first thing I showed you, the AirPin, was the very first thing we patented because it's the most powerful combination of the technology. And we said, well, we have a patent, but if we were NVIDIA and we own the chipset, how would we get around this patent? If we were Microsoft or Apple and we own the operating system, how would we get around the patent? And we just tried to go to each layer of the technical stack and engineer our way around our own patents. And we had those all ready as continuances. So as soon as we got the core patent accepted, the next day we filed all the continuances, and they accepted those 2 months later. They were like, wow, all of those make sense, right? You're not, and he said, you're still not at the boundaries of what I'll approve. So then we have to say, okay, now let's get into the design and the use patents and all the other things. So for us, we spent probably $2 million on patent work in the first year and a half, just keeping, because we were writing so many of them, And even
Right.
though we had a fairly efficient team, and we'd already decided on, how to get the patents filed as efficiently as we could, it was just still really interesting to see how Oblong worked and how successful they were. So I give them full credit. I mean, they were masterful at what they do for a living, and they were also open and very effective in working with co-counsel who were not from Oblong, but were specialists in different areas. And those guys kept us clean, right? They were telling us when we were missing something, or our language wasn't going to be understood or wasn't going to be effective in what we were trying to cover. So I would just say, stepping back and looking at it and being willing to spend money. Every one of our investors said, don't spend money on patents.
Really?
And they all said they're useless, right? Because the big guys they're just going to step on you anyway.
Right. Yes, we hear that.
And we said, well, we don't intend to use the patents offensively. That's not our intent. Our intent is just to defend ourselves, to have the right to go take this technology into the market and not have somebody come and tell us that they invented it, right? And so we said, look, if we think we have a horizontal class of technology, then we should invest in the patents. If it was just a product, I would have agreed with them. I wouldn't have wasted the time on a patent because the industry is not going to respect it anyway. Right?
Sure.
They're just going to step on the patent and say, I'll meet you in court when you're out of money and I'm not, because I made all the money using your patent, right? So that's kind of how we approached intellectual property.
Thank you for giving us that masterclass. There was many, many useful takeaways there. I certainly appreciate it.
Sure.
We're getting close to the hour here, so I want to end on an important question. One of our missions at IDiyas is to reach the next generation of innovators. Imagine maybe a young person who listens to this and is inspired by what you've accomplished, wants to make an impact with their career in innovation specifically. What advice would you give them?
Well, first of all, make a lot of friends, because I find the process of inventing to be very collaborative, right? I know a lot of people are brilliant and just come up with brilliant ideas, but a brilliant idea is not worth much if you can't execute it, right? So finding out how to work in an environment where people will collaborate with you and help you be successful, and will actively help you go through the hurdles of invention, because nothing I've ever done has felt easy when I was doing it, right? So, I always feel like I'm not going to get there. I'm not going to be able to get over the next hurdle because the hurdles are hard. But a network of people that are willing to collaborate and to work with you, and honestly, just to give you the confidence to keep going when it's hard, is probably, from my perspective, one of the most important things in actually getting from something in your head to something in the market.
I think that's phenomenal advice. Commercialization does not happen by one person ever. And so I don't think that's a message that's being spread loudly enough. People, I think, oh, if I want to be successful in my career, I have to forget I have friends, as opposed to realizing that relationships are the essence of what we're always doing. I think this has been absolutely phenomenal. As our meeting draws to a close, please, everyone, if you would share your appreciation for Mike in the chat box. Where can we go to stay abreast of everything that you're doing, Mike? Should people connect with you on LinkedIn? Do you offer a newsletter? Would that be appropriate? Okay.
Well, they can easily just reach out to me at mike@mobius.com. So my email is easy. I'm also on LinkedIn. I'm pretty easy to find. So please connect with me. I've got some notes here, some follow-ups that I see in the chat box. So I'll follow up with people that left messages there. Thank you. And I noticed several of you are from the Atlanta area. And I spent most of my career in Atlanta. Now I live down near Rosemary and Alice Beach on 30A. But my daughter's there at the Shepherd Spinal Center in Atlanta. So I'm there on a pretty regular basis. So next time I'm there, maybe we'll get a chance to catch up.
That's wonderful. I'd really like to thank you for your time and being so generous with sharing your insights with us. Thank you, everyone, for joining us for the 5th interview in this IDiyas series. I'd love to know what you thought of our conversation. You can provide feedback directly by connecting with me on LinkedIn, or you can email support@IDiyas, IDiyas.com. Let us know which and who are the inventors you'd like to meet next. We'd really love to know. And we will see you all very soon for our next event in the IDiyas series. Thanks, Mike.
Thanks. And thanks everybody for attending.
Bye.